This media was gratuitously produced by Clear Contributions Audio and Video. The intellectual property contained within belongs to Dr. Barbara Van Kuyken. Clear Contributions. Let's have clarity.
Okay, let's check your work and I'll answer the questions that popped up as I went around and checked everything. So the first one, you have carbon, chlorine, oxygen, and hydrogen, 4 different atoms. So you're good to assign the priorities directly. Chlorine is 1, oxygen is 2, carbon is 3, and hydrogen is 4. The number 4 priority needs to be on the hatch line because it needs to be going away from you to be able to directly see what you're doing. It is, so you can just trace 1 to 2 to 3, just bypass 4 and ignore it. It's in the back anyway. And since that is going left, if you're turning a steering wheel, that's S. Yes?
So where I'm getting confused with the R and the S is that you can turn them either way and get the same thing.
That's why I'm mentioning a steering wheel, because it's very common for students to say, how can that be R, for instance, or how can this be S? Because it's at the bottom, it looks kind of backwards, but you got to think of it in terms of a whole wheel, and if you were turning your steering wheel this way, your car would turn right. The bottom's going like this, but the top's going like that. So you got to think in terms of the whole circle.
But if I do the same thing the other way, I can still get them in the same position.
What do you mean the other way and in the same position?
Well, if I take and turn the steering, so turning left, I can get this to this position.
When you're going 1, 2, 3, you have to show, or you have to look at what direction the arrow is going when you go 1, 2, 3.
Oh, so we're not moving the molecule.
Right.
Okay.
Correct.
Okay.
This is just an artificial description of how 1, 2, and 3 are oriented relative to each other. You're not spinning the molecule. Good question, because that comes up quite often. I'm glad you asked that. Any other question about A? All right, and we did B in class, so I'm not going to waste time with that one. All right, C. Oh, look at 4 different atoms directly attached, so you can determine the R and S without having to go out to the next layer, or I'm sorry, the priorities without going out to the next layer. The problem this time, though, is going to be that your number 4 priority isn't going away from you on the hatched line. So bromine's 1, nitrogen is 2, carbon's 3, and hydrogen's 4. You could do the priorities that way and just sit there and rotate the molecule in your head and figure out where 1, 2, and 3 end up, but that's usually hard for most students, so it's kind of a, why don't I have 4 on the hatched line? Well, then put it there. By swapping it with whatever you need to swap it with that's on the hatched line. So now 1, 2, 3, that's R. But you switch 2 things to decide that, so when you put it back, that means S. Good? Okay. Chlorine, carbon, carbon, carbon. Oh, bother. All right, so there's priority 1. Now you got to do 2, 3, and 4 based on the tiebreaker rules. I'm going to make this a different color just so that it stands out a little bit for you there. You're looking at whatever's attached to the atoms that I've highlighted in red, the ones that are directly attached to it. So you have hydrogen, hydrogen, bromine, hydrogen, hydrogen, carbon. I'm sorry, I'm not doing a very good job highlighting today. Hydrogen, hydrogen, carbon. I need to make the highlighter a little smaller. All right, so you have 1, 1, 35. 1, 1, 6, 1, 1, 6. Looking at the third number in each list because you're looking for the largest atomic number, 35 is clearly the largest, so there's priority 2. Now I'm going to cross that off so we don't look at it anymore. But the other two are the same number, 6. So you got to go to the next atomic number. 1 versus 1. 1 versus 1. Since all 3 are tied, then we got to go to the next layer out. So you have whatever's attached to the carbon that's highlighted in blue here. So that has 2 hydrogens and a carbon, and this has 2 hydrogens and an iodine. So, just a minute, I'm going to highlight that in blue. That was the blue layer. Okay, now for the green, you have over here 1, 1, 6, and over here you have 1, 1, 53. Looking at the third number in each list, 53 is higher than 6. We're trying to decide between 3 and 4, so that means the higher number is 3, and this one's 4. Uh-huh.
So it wouldn't have been 1, 1, 1.
For which one?
The green, not the 1, 1, 6.
Oh, I see what you're asking. This one right here.
Yeah.
So you're looking at what's directly attached to this carbon.
I'm done. Sorry.
You good?
Yeah,
Okay.
This might be jumping the gun a little, but after you already know what number 1 and number 2 are,
Uh-huh.
does it matter what the other two? Because you can already see that it's going right. Whether
You need to have number 4 priority, though, going away from you, so it is important to know whether that's going away or not,
Okay.
where that is located. Good. So it worked out okay this time that you didn't have to know that, but sometimes it might not, so you still need to do that. So 1 to 2 to 3, bypassing 4, that's R. You didn't have to switch anything to figure that out, so it stays R. Any other questions about that
If
one?
3 and 4 were switched, then you have to switch them, and that would make it S.
That's right.
Okay.
Okay. 6, 6, 6, 6. What is attached to the red carbon? 2 hydrogens and a carbon here, 2 hydrogens and a bromine, 3 bonds to nitrogen, and chlorine. So those are all different. Hallelujah. Okay. 1, 1, 6, 1, 1, 35, 7, 7, 7. If you have a triple bond, you write the 3 attachments out. If you have a double bond, the 2 attachments. They each get the number to the atom they're attached to. So let's see, chlorine is 17, 17, 17. You're not looking for the biggest small number, you're not looking for an average, you're not looking for anything else, just look at the last number. There you go. This is 1, 2, 3, 4. Are you okay with deciding the priorities? All right. I don't want 4 there. It needs to be on the hatch line going away so that I can directly trace around. So I'm going to swap it over to here, and that means 1 goes here. 1, 2, 3. That's S. But I have to put everything back, which means it will make the mirror image. So that was an R configuration there. I'm not seeing the pencils coming out very much, so that's good. Looks like good. Okay. 6, 6, 6, 6.
Okay, so yeah, question actually.
Okay.
So this one I was wondering about, like, which carbon it's attached to when referring to the one on the left.
Okay.
How are we supposed to know that?
So remember that when you have any hydrogens are usually, unless it's the very end, attached to the carbon that's just to the left of them. So
So
Yes.
how do I know which atom is attached to, like, the main carbon?
The main one?
So like
This one here?
yeah, how do I know which molecule is attached to that main one?
Okay, good question.
Which one bonds with it?
Yeah, so you know how when we have been writing out molecules like this, and it's like these hydrogens are directly attached to this carbon, these hydrogens are directly attached to this carbon,
Right.
and so on, but these carbons are attached to each other. That's the backbone that you're
Okay.
looking at. So if you keep in mind, these hydrogens are attached to that carbon, so they're coming off, and that means this carbon is attached here.
Okay.
And it's the same thing here. This carbon's attached to this one, these hydrogens are attached like that.
Okay.
Okay. So, one, 6, 1, 8, 1, 6. Highest number, lowest number. So there's 1 and 4. Next round. But this is why I was saying maybe it's helpful for you to highlight the different layers in different colors, just because sometimes you start losing track when you're just looking at it on a blank piece of paper and like, where was I? Where did I leave off? This one and these two and the bromine. Okay, 1, 35. Oh, hooray. Okay. So there's 2 and 3, because those are the two we're trying to decide between. 4 on horizontal is horrible for Fisher projection, because those are the arms reaching out to you to give you a hug. This is on the vertical, so you're good to go. 1, 2, 3. That's R. Oh, this is making me happy. I'm seeing lots of... Oh, good. These are different. 8, 6, 7, 1. Woohoo! So this is priority 1, 2, 3, 4. Four, or hydrogen on horizontal, is horrible for Fisher. So we gotta move it. You can move it to either of the vertical and you'll get the same answer. I'll do it both ways just so that you believe me. So you could have 4, 1, 2, 3, in which case you go right, but when you put it back it's S. Or if I would have switched it with the one below, 2, 4, 1, 3, 1, 2, 3, R, put it back, it's S.
Wait, what do you mean by put it back?
So I switched these two because I don't want 4 on the horizontal.
Okay.
To figure out what the stereochemistry is of that modified molecule. But the question wasn't what's the stereochemistry of the modified molecule, it's what's the stereochemistry of this one. So it's like, well then, if I've switched 1 and 4 to figure out stereochemistry, then I have to switch it back to put it back into the original configuration here. Does that make sense?
Kind of.
See, for instance, on this one here, what I did to figure out stereochemistry is I switched 2 and 4.
Yeah, but if you take a molecule and you move it.
If you can do that in your head and come up with the correct stereochemistry, go for it.
I'm getting the wrong stereochemistry question. That's why I'm confused.
Oh, okay.
Because if you take, because right now it's leaning forward.
That's right.
If you just take it and shift it like that, then you'll have the proper orientation.
Now,
It does have a 1, 2, 3.
because if you shift it like that, now you've got the vertical coming towards
pulling
you.
it out and back like that.
Yeah, and then you'd have to rotate it. Yeah. And if you can,
build it and see if I'm just thinking wrong.
okay, that's a really good way to check. That's what I'm saying. A lot of times students can do that where they can rotate stuff in their head. I can't do that and come up with an accurate representation. I think most people are like that. And so this is how you work with it on paper if you can't quite picture how it rotates.
This was the only one that sent me for a loop.
This particular one here?
Yeah, that's
Okay, what caused you to...
I can imagine what it like usually.
What it looks like when you flip it around?
Yeah.
I was kind of saying in class yesterday, if this is coming towards you, then you have to rotate it like this so it's going away from you, which means that this moves over if you spin on this axis.
Yeah.
So if you wanted to do it mentally, then you could flip this over so that the 3 is over here and then go 1, 2, 3 and it's S.
Yeah. I always just pull the top one down.
And the top one's going away from you.
Yeah, so I pull it down under and have a triangle and the H is behind.
Oh. Okay. Are you seeing where you got it?
Yeah.
Question.
Yes. Got it.
Okay, so that's what I said. If you prefer to twirl it around in your head, what you're trying to think of is the hydrogen's coming towards you. You have to have it go away from you. So notice that this moves over to the other side. If you're spinning on this axis, these stay in the same place. This flips over to here.
But the vertical ones stay in the same place.
Right. So then if you did that, and you've got 3 over here, then when you go 1, 2, 3, that's S. Okay, all right. All right, we'll finish this up. Carbon, carbon, carbon. Nitrogen, hydrogen and bromine, hydrogen and carbon, hydrogen. 7, 7, 7, 1, whoops, 35, 35, 1, 1, 6, 1, 1, 1.
Where's the 6 go?
I don't know.
It disappeared.
So this is priority 1, 2, 3, and 4. Oh, bother. 4's in the wrong spot again. That's how much I love you. So if I swap them, 1, 2, 3, S, that means originally it was R. Or you could move the 1 over to the other side and go 1, 2, 3, and then it's R. Well, do you need more practice or do you feel okay? More practice? I think I've got some more at the end. We can quickly check and see if there's something I can assign here.
Which is right.
I'm going to have to show you a couple more things before I can assign something from the back. So I will give you some more practice, just not tonight with that. But what I'm going to give you for practice is very related, so it will still give you some of the practice that you're looking for. Okay, some molecules have more than one chirality center. So what do you think you do?
You label them RS wherever you label anything. Are you talking about naming or?
No, I mean just how do you decide R and S if you've got more than one chirality center? What do you think?
Oh, I would assume you R and S for both of them.
So the essential idea here is that you're looking at one at a time. And so anytime that you have to do two chirality centers, I've put in the book for you 2 copies of the molecule, because otherwise it's going to get garbaged up with all of the priority labels and everything, and then you got to do all the priority labels for the other one. You're going to have so many numbers on there, you're going to get totally confused. So I would suggest that as a good common practice for you also. It's worth the extra pencil lead and the extra 5 seconds to redraw it if you need to.
So you just compare one at a time then?
Yep.
Go.
You just do one at a time. So I've got examples here for you. Notice that I just have a thing over to the side that says for the top, we're only going to look at this chirality center right there. And look at what's directly attached to it. So you have a carbon, an oxygen, a hydrogen, and then the other chirality center carbon is also directly attached to it. So just don't let it throw you that you've got that the next chirality center carbon is somehow different. All right, so you have 1. It says an atomic number of 8, and this is 1, that's 6, and this is 6. So, no, go away. Priority 1 and 4. I'm seeing some unibrows. What's the question? Uh-huh.
How do you know that the bottom part, so like the one that doesn't have like a CH, just like the bottom one?
Yeah, I think I know what you mean. This. That's the representation for a Fisher projection. Is anytime you see where it crosses there, that's a carbon. It's just that it's a chiral carbon, and so it's got a specific stereochemistry represented. Right? No, that's a question that a lot of people were asking mentally. I'm glad you asked it. All right, anything else? All right, you got a tie. So look at what's directly attached to the stuff that I've highlighted in red.
Is there a reason that you chose? Oh, okay, I get it.
Okay. And that's what I'm saying again. Maybe highlight each layer, because otherwise when you get down to the chirality center, it's like, what's attached? I'm confused. And you kind of, I don't know, lose your place in space somehow.
And can you attach bromine and on the same side the oxygen, because oxygen is attached first to the chirality, not the hydrogen.
I'm sorry, what, the bromine here?
Yeah, bromine, I got that, and then you did oxygen, not hydrogen.
Go get it.
Yeah, so I'm just trying to break a tie between this and this. So I'm just looking at what's directly attached to it, and that's all. Just those 3 atoms here and the 3 bonds there. Whoops. 1, 8, 8. 1, 8. No, what have I done? Sorry. 6, 8, 35.
Where did you get the 8?
No oxygen.
Oh. You went like this.
She puts them in order of biggest to smallest.
Oh.
Doesn't matter which one is less. For sure.
Yeah, if I do smallest to biggest, then that way I can just always look at the third number because the highest number is what's breaking a tie. And you could write them in any order. It's just that I'm OCD. So anyway, I mean, then you have to sit and search through all the numbers and everything. So and it keeps you kind of focused.
Doesn't matter, it's still attached to the car.
She hasn't signed it.
So it's 35.
Carbon.
You what?
Still attached to the
Yeah, 35. Yep. So this one is 2. Did it again. This one is priority 2, and this one is priority 3.
Only the oxygen attached to carbon.
So Dr. D, why
Yes.
did you do the carbon with oxygen and bromide instead of going like the CH2? How did you, does that make sense? Why didn't you just go the CH2 when you were doing for trying to decide?
Because when you do the tiebreaker, you're always looking at what's directly attached to what you're breaking the tie of.
Oh, okay, I see. Okay.
Yeah. You just go the next layer. You don't keep going out from there. It's just the next group of atoms. Good. Any other questions before I garbage this up even more with numbers? All right. So I'm going to, number 4 on horizontal is horrible for Fisher projection, and this is a Fisher projection, so I got to swap it. Or you can mentally rotate it, whatever your brain's up to the challenge for. What questions? Or if you wanted to, you could move everything, twirl everything around to put number 4 in back. So you're moving that over here. This is 3, 2, 1, 2, 3, S. If you want to twirl it. All right, you're so smart. Do the bottom one. So you're looking at this chirality center only. Start with the atoms directly attached to it.
I made it for too.
Oh, no.
Thank you, Bill.
Why did you cross out 8 on the top?
Okay. I'm trying to break the tie between this carbon and this carbon by going out to the next layer, which is highlighted in blue. Okay, so this is 168, 118. Are you okay with how I highlighted it and decided what I'm comparing in the next step?
I did not know you were going to compare the top and the bottom. I saw how you did 2 and 1, and I was okay with
Okay.
that's good. And then I didn't see how you went to highlight on the side because you went to the top, I see 168.
So I'm highlighting anything in red that's directly attached here. So that's those two, and then these 2 carbons, right? So then I've got bromine is high, oxygen is next highest, and then the carbons are a tie. Because the carbons are a tie, I'm highlighting what's directly attached to the thing I've highlighted in red here, the carbons. So it's these 2 hydrogens and oxygens are attached to this carbon. This carbon has an oxygen, a carbon, and a hydrogen directly attached to it.
And it's also the same 1 on 8. And so number 8, you cross that, and then you're going to go to the one next to it.
That's right. So I start out comparing those 2. Since they're the same, I've crossed them out, and then I'm comparing the second one. You're very welcome. Anything else? All right. We'll finish up with B then. This is a perspective formula with 2 chirality centers to it. That's how it's drawn because bonds like to be staggered because electrons want to get away from each other. So this is a familiar way to represent 2 chirality centers with a perspective formula. Now you see that once you get more complicated molecules, it's usually easier to just do the Fisher projection. But it's the same exact process. You look at 1 chirality center at a time. So I've got the left one first on your list. And you look what's directly attached to the chirality center. You have a tie for 2 of them. So you're going to have to go out to the next layer. But you can assign priorities 1 and 4. So for the ties, you're looking at what's directly attached to the carbon that's highlighted in red.
This way? If it's shifting this way, it's S, right?
So if it's going counterclockwise, it's S. Okay, this has the same issue as before. If you have a perspective formula, you want it on the hatch line because that's going away from you. 1, 2, 3 is S, but I switched it to figure that out, so the original was R. So I have the 4 here, but I need it here. So I've swapped them.
Wait. Wasn't it if... Oh, never mind.
Okay. All right, so then there's the right one. We'll finish up with that.
It originally was an S, but it became an R.
Let's see.
Yeah.
So it was an R. You just didn't know that because you had to switch these to figure it out. So you always make the mirror image when you do that. So I switched it into place so that I can figure out, and it's S. So that means it's backwards because I switched. So when I switch it back, it becomes R. Because anytime you switch two things, you make the opposite. So because this is not the original molecule, when I have it like this, I have to put it back and then change the stereochemistry. You're welcome.
Doing counterclockwise is nice.
Luckily, 4 it wasn't a hatch.
Right, exactly. So now you can just go 1, 2, 3, and one, whatever you decide this configuration is, it stays that way because you didn't do any switching.
I guess once you switch number 4 to put it in the back, that's when it gets a little cluttered.
Yes, exactly. You doing well? Okay, whoops. Yeah, we'll do C tomorrow or so. C is going to make you bitter anyway, so. We'll keep that until Friday, so that, yeah. I'm going to give you some homework that isn't directly related to this because I have to show you one more thing before I can give you related homework. But I need to keep you practiced on naming. And so, nope. Practice, refine, all lab book. Yeah. On your chapter 1, I've got a very good exercise for you to keep you polished on how to name the molecules using the first 4 steps. What I'd like you to do is problem 4. If you're looking at the workbook, it's pages 33 and 34. All of these are incorrectly named. So what you need to do is draw it out, if you can, based on the description, and then state what's wrong with it. So what you can do is you can draw it out and just ignore the directions from there on out and just name it based on what you think it is. But what's the error with the first one? If it's, you don't need the 3 there.
Sorry, yeah.
Yep. You don't need the 3 there, and so just cross it off and just rewrite it but2ene. In the process of correcting mistakes, a lot of times that really helps lock the rules in for you. All right.